Good afternoon, everyone. Over the last 3 days, I'm pretty sure we were all enthralled to great topics, and I could see the passion with which all SREians have exhibited over the last 3 days. We've all been keen on building reliable solutions, systems, and also focusing more on the best customer experience that we could all offer. Kudos to all of you for doing that. And in that journey today, Anant and me from PayPal SRE are here to share our experiences on evolving from an end-to-end customer testing platform and enhancing it to synthetic monitoring. This is a specific use case, and how we evolved in this journey is going to be the deep dive topic for us. And as many of you may agree, evolution is better than revolution. So we are in a quest for highest reliability, and one such signal that we thought we could tap on is on synthetic monitoring. We will cover the following topics. Specifically on synthetic monitoring, we will do the industry introduction for synthetic monitoring, and what and why we needed synthetic monitoring in PayPal. We'll talk about in detail on the end-to-end testing platform that we have already, and then look at the architecture, the design, the constraints that we went through, along with the challenges. Hopefully, we will also have some feature takeaways for all of you in participating in this talk. Setting up some context, what is at stake? And I just want to give some background on PayPal so that you understand why and what our mission is as PayPal SREians. As many of you may know, PayPal is a two-sided network, and we support both merchant business as well as consumers. With our Q1 results this year, you could see that our payment platform has processed 5.8 billion transactions. We supported 433 million active accounts. Our tech stack is pretty complex, with residing on both cloud and on-prem, distributed across multiple AZs. We have over 3,200 applications and services offering various capabilities like web, mobile, and API offerings to support this business. With the strong business model that we have in PayPal, what is the best that we could offer in terms of our customers is the highest reliability. With highest reliability, we would be able to create amazing experiences for our customers, and that's where comes in PayPal SRE. We've handcrafted this vision and mission for PayPal SRE, and I'll touch a few points on this so that you would understand how we went on our reliability journey. Our vision is to create the most reliable payment platform on the planet, and our mission is to build and democratize an AI-driven reliability engine that builds trust by powering highly reliable customer experiences. The mission was crafted recently, and we have started to invest more on AI into looking at our reliability engine. We've had various platforms over the years that we have built in PayPal, in various domains, especially we have changed reliability, which is one particular domain in PayPal. One of the tools that we are going to use using there is the end-to-end testing platform, which we will be covering in this session. Last year in the SREcon APAC, we presented the impact assessment automation, which is from the measurement and attribution domain. We also have site health restoration and other domains where tools and platforms are built. Having all these tools and platforms, why do we need synthetics? And that brings us to the topic here for today. With the observability platform that we have and the various signals that could indicate any incidents that could occur in PayPal, what is the gap that we are trying to solve with the synthetics monitoring platform? That's where customer experiences and feedback, along with performances in various geos, comes into the picture. Every incident, we did a detailed study on 2022 incidents from PayPal, and we thought there is a potential opportunity to tap in wherein we could build another additional reliability signal in synthetic monitoring. Through synthetic monitoring, we could potentially or proactively identify performance issues. Our mean time to triage or mean time to resolve may be reduced. We are doing various launches in markets across various geos. If we have a synthetic system that could tell us the customer behaviors in those markets, we would be able to launch new products. We may meet the performance goals, SLOs, and other benchmarks. Last but not least, synthetic monitoring is needed for our partners and merchants who rely on our communications. With synthetics, we would be able to provide the exact impact and the customer behaviors during an impact, as well as promise them with the right recovery status whenever there is an impact that has just occurred. With all this, let me do a quick round of industry definitions for synthetic monitoring. I think many of you would know it. Synthetic monitoring is a monitoring technique that is done by using a simulation or a scripted recording of transactions. It is also called as digital experience monitoring, DEM, and some people also refer to this as synthetic transaction monitoring. So how does this work? Basically, this is an end-to-end flow automation that is simulated to run and replicate an end-user experience and validate our site, application, or software. These experiences our end-to-end tests are continuously executed in specific intervals to monitor the performance, functionalities, availability, and other response times. So how it works in PayPal is specifically an end-to-end experience running every time as an automated test. So what do I mean by an end-to-end test? I mean, starting from a merchant-initiated transaction with an API, and then a web experience where the customer logs in, does a checkout, and then a completion of a transaction where the merchant pays another or calls another API. So all of this constitutes a single end-to-end test. And this type of monitoring is not actual traffic, but as I said, we are simulating these with tests, and the tests are authored by our own teams, and they are executed across, like a customer, in various geolocations, and that's why it's called synthetics. And the crucial part is these are live transactions. By the way, the scripting is automated, but we perform live transaction with test accounts. So the actual money movement also happens so that we can definitely verify the end-to-end experience there. So now that we understood and realized that synthetic monitoring is needed for our use case and it could be a potential reliability signal for us, we went ahead and drafted these requirements. And again, these are specific to PayPal, but we thought we have to curate these requirements. And only with these requirements, we will be able to come up and build or buy a platform that could suit our needs. So what is the scope here? We wanted to support all the flows that we have within PayPal, and not just for the core business, but also for our branded BUs, which is like Braintree, Venmo, and others. We wanted to support the geolocations and also be multi-channel, verifying our web, mobile, and other experiences we want to validate. Of course, all our APIs, customer-facing APIs needed to be validated. We also wanted this platform to support all our environments, which is production is one, and we also have an integration environment for our merchants to have, execute their transactions before going live. So our scope wanted to be broader to cover even that. Now that we have a broad scope, we need also look at coverage. What are the type of tests that we want to automate? We targeted first the partners in high volume flows because they are unique integrations and they have specific flows. A checkout with eBay is different from another merchant checkout, and the experiences vary, though it is all from PayPal. So we wanted to ensure that our high volume partners and merchants are included in the end-to-end flow coverage. We wanted to have the total TPV or the total payment volume coverage as well for our flows, because some flows may yield more transactions per volume and payment volume, and we wanted to have them as critical tests running into this. New product launches, which I already shared, and as well third-party APIs and endpoints. We have a lot of integrations. We want to ensure these synthetics tests validate those third-party APIs and endpoints. We also wanted to touch base on the Web Vitals. Like most of you would know from Google, the Web Vitals, there are 3 specific areas that we wanted to focus on: loading, interactivity, and visual stability. There are metrics defined by Google standards. We wanted to build or we wanted to have these capabilities within synthetic monitoring, specifically largest content paint, which is the time it takes to load the largest content in the web page or the largest element in the web page. Usually, the benchmark value is 2.5 seconds there, and we wanted to benchmark around that so that our experiences are validated. First input display, or FID, is nothing but the interactivity, that is from when the user interacts with the web page till the response comes out. Usually it is targeted to be 100 milliseconds, and we wanted to have it below that. Cumulative layout shift is the visual stability. We wanted to ensure that the visual layout and the page has a specific layout look to it. It's actually measured in 0.1, and we wanted to stick to that. And most importantly, we wanted to also have AppDex, which is Application Performance Index. This is specifically what the ratio of the satisfactory and the unsatisfactory response times. So we wanted to ensure that every time a user comes in, if we benchmark as 2 seconds, every experience that takes below that is satisfactory, and every experience that takes above it is unsatisfactory. Other user experience measurements include DNS time, connection time, SSL handshake, total download bytes, and two most important components that we wanted to have in our requirements are trending over time, which is the average response times over a period of time, which can be linear or histograms. We also wanted to validate web performance long trails versus the average. So this actually shows the deviation from how our performance or how our apps are performing based on the median values. Non-functional requirements, or NFRs, and others are also included here. I'll call out a few of them. These are synthetic tests that are automatically running from various geos, but we wanted to ensure, give the scope for our SREs and command center to manually rerun them, and have all these inbuilt performance measurements. All of the measurements that I told you before, all of these metrics needed to be tracked with inbuilt measurements. We wanted to have session replays so that we capture the experience whenever there is a failure. We wanted to avoid dependencies, security requirements, including audit logs, credential rotations. As you can see, these are live transactions, so we wanted to preserve the security of it. We want to also focus the observability needs when we need to triage such test failures, which including the screenshots, the debug IDs that we could provide, change logs. We also wanted to have alert management. Like a system should be able to configure these alerts and user privileges. So this was a 5-pager curated requirements that we came up with, but I've listed the top ones here just to show the practice of when we start building a platform, we've also wanted to cover all these requirements first before deep diving into the implementation. Two primary use cases that I wanted to call out. Though we know that we needed synthetic monitoring platform and we are taking this journey on the design, the most important use cases that we want to ensure is our product development teams already have end-to-end tests for their validations of various flows. We cannot create a system where they have to re-author tests and bring in the system, put it in live, right? So we need to provide them an opportunity to configure their end-to-end tests to run as end-to-end synthetics. So that's a very crucial part of expanding this platform. So that is one use case. Our existing end-to-end test cases in whichever native language that they've authored should be agnostic and run in the Synthetics platform. Another important step, which became a crucial criteria for us to decide, is whether the synthetic monitoring platform is able to support both API and web combinations. As you can see, many of our experiences are not just on one web experience. You would have seen in multiple synthetics where people provide record and playback, it's only the web experience that is validated. But when you think about the synthetic transaction monitoring in PayPal, it includes also the API step along with web, and then again an API or a combination of API and web to complete the flow. End-to-end test is like that in PayPal, and we wanted to ensure that both the web and API combination is supported. So these 2 points become really relevant when we did our analysis and design going forward. With that, I'll hand over to Anant to talk about the design and the journey we took prior to this, and we'll also deep dive into our end-to-end testing platform. Anant?
Thanks, Rex. So good afternoon, everyone. I'm Anant. Till now, we have heard from Rex what is synthetic monitoring, why we need that. I'm going to take you our journey of how we have designed and implemented, how we have evolved our already existing end-to-end testing platform to a synthetic monitoring platform, right? So with that, we have produced a high-level design on where we have conceptualized all the requirements with this design. So at the bottom, you can see where really our synthetic monitoring platform want to exist. It should be somewhere out of the PayPal. Basically, it should be at the customer geolocation where all the requests should be like simulated from like a actual customer experience, right? So those requests should go to a browser and device farm. It should be agnostic of any limitations to any set of browsers or devices or versions, right? And those requests should be similar to what our real customer experience in those locations. And in case of any failure alert, the SRE should be notified through a PagerDuty alert or something like that. And those requests should be processed by our own availability zones with the router. So this is a very high-level design we have conceptualized. And with that, we have went into the market and started evaluating various vendor offerings. And we wanted to learn and explore the industry trends and capabilities that are already available in the synthetic space. So we have brought up these set of criteria with which what we have evaluated. I'll go through one by one. The first one is the API monitoring, which is very critical for the merchant integration. So we will have a lot of customer exposed APIs. So those should be monitored not only by the health, but also the performance measurements, right? Those should be monitored with all those error codes, status codes, latency, performance benchmarking, everything should be validated. So that is the first criteria. And the second thing would be multiple step level transaction. Like Rex said, any checkout flow will be involving a web flow and a combination of API flow. So those step level transactions should be monitored, and we should be benchmarking that at each step level. And the framework support. If we want to federate that synthetic platform to the product development engineer or development team, a lot of framework support should be in handy. Like if I want to write the test in the Java-based TestNG or plain JavaScript test or a JavaScript test based backed by WebDriver IO or a Cypress test, these frameworks should be in support. And it should be supporting all those devices. Like it could be OS or multiple Chrome browser or a Mac browser. And all the versions should be supported. And since we have a lot of flows covering in the mobile application, native mobile application testing in the synthetic space should also be supported. And with that, we are going to build the perform measurements, and it should be available in multiple global locations. With that, we are going to benchmark the availability and performance of various web flows and the APIs. So the one another criteria that we had is testing in pre-production. As a product development engineer, if I want to test a specific or run a specific test in a pre-production environment so that I gain confidence so that my customer or reliable or the experience is going to be reliable, I should be able to test that in a pre-production environment, right? And also I should be able to manually execute it. And the final thing is the dashboard. So once I have all these test execution in running, so I want to view in a dashboard with the heat map, the performance, and the execution and the past history so that we can show how reliable our customer experiences are. So these are the vendor evaluation that we have done. We have picked up around 30 vendors in the market, and we have selected top 5, and we have done deep working sessions and POCs with those vendors. After doing those vendor evaluation, we have ended up in a set of constraints for this external setup, right? So as SREs, we strongly believe that security is a key forte of PayPal customer experience. So we should be aware that while we set up some synthetic tests outside of PayPal network, the safe transfer of code and the artifacts will play a key role, right? So we have to find a way to securely transfer our code or the artifacts outside of our network. And the second thing would be security of data. Since there are real customer accounts created with the test flag and the money movement happens here, we need to be cognizant of the credentials, auth tokens, logins, email, passwords are being used here. So that should be taken care. And application ownership. When it is externalized, it could not be or should not be limited to a specific set of users to use, right? It should be federated to the entire product development team so that the ownership can be scaled. And finally, the application and monitoring of that synthetic, so how reliable that synthetic monitoring application is going to be. So with these constraints, we thought of why not leverage the end-to-end testing platform that we already had, which we called as CFBT, Customer Flow-Based Testing. So this is an in-house product developed by SREs and platform engineers. So it has a test runner with multiple framework support and a dedicated data center, a fully deployed system where we run the end-to-end tests for every releases. So if I want to release a component, it will be deployed in the end-to-end testing platform with the dedicated data center, and all those end-to-end tests covered by that component will be run. So the developer gains the confidence that my changes is going to be not affecting any customer experience, it is going to be reliable. So that is the main aim of this end-to-end testing platform. And what are all the key features that it provides? Every test that has been executed is from the customer point of view. We are going to use the real customer accounts with the test flag, and it's going to vet every releases in an N+1 environment. So what do I mean? Let's say if I have a component A, B, and C, if I'm going to release a new manifest for the B, the new manifest will be deployed in the dedicated data center, and the flows that is going to cover this A, B+1, and C will be run, so that I get an confidence that my experience is not my release is not going to affect the experience, and it is a final gate to delivery. So once the tests are run, it will give you a decision of go or no go. So based on that, you can decide on whether we have to look at the test, or if there is any failure, you can action on it. And the fourth thing would be the command center or operation people. If they take out any data center out for site mitigation, and if they want to put again into actual traffic, they can run the entire suite of tests against that particular data center, and they can gain the confidence. And finally, the continuous monitoring. So we can run this end-to-end suite of tests dedicated to a particular data center constantly, so that we can monitor that particular data center is serving the actual traffic in a proper performance measurements. So I would like to take you to the specific routing logic, how we route the end-to-end test request to a specific data center. So if you see that the yellow part boxes will be our end-to-end testing platform, which actually resides in the mid-tier zone. So any test when it is run, the requests are being routed by a dedicated routing logic that we have to a specific data center. So it will reach to a front-tier component or a mid-tier component based on the request, be it an API flow or a web flow, it will be reaching to a specific data center. But an actual customer, from the customer perspective, it will take an internet gateway, it will reach out the border router, and it will be served by any of the data centers by the routing logic. So this is the key differences between how we run the end-to-end test with a specific data center and how the customer requests are processed. So if I have to zoom a little bit on the test execution part, there is a parent container that backed by the Kafka queue ensures thread handling for seamless execution across the distributed nodes. And for every execution, we have a set of child containers to run the specific framework test. We have Selenium Hub, Chrome, and Firefox, and we have a dedicated container for the Cypress test. And we have a common test directory that is shared across the nodes. So if I want to scale up the nodes to run the test, the shared volume comes in handy so that we can span in a few minutes. And the another service is dashboard and package management. I will go into detail of the package management in the next slide. So this is at a high level how our text execution happens in the end-to-end testing platform. So next, test authoring and framework support. So this end-to-end testing platform is not limited to our platform engineers or SREs. It is federated to every product development engineer in PayPal. So as a development engineer, I just need to write that end-to-end test and check in the code in the GitHub. Our package management serve will automatically pick up the code, and it will versionize, package the test based on the test framework. It will assign a version, and we have an APIs in the testing platform to activate and deactivate it based on the release. Our executor service will pick up those test package, and it will run the end-to-end test. It is this end-to-end test platform is part of the release pipeline. So whenever I want to release a new manifest in the production, this end-to-end testing platform will automatically identify the flows associated with that manifest, and it will run end-to-end test, and it will give a go or no-go decision. This is with respect to how we federate this platform to a product development engineer. So how we evolve this testing platform for synthetic monitoring. So we have end-to-end test running to a dedicated data center, but we wanted to test the same thing from the customer perspective. So we have in the right side, if you see the green boxes, now we have the testing platform. We did minor tweaks, and we have added config specific to a synthetic for the test to map it to synthetic. And We have set up an external cloud setup where it has a Selenium farm to run those tests, agnostic of devices. We are going to route those requests to this external setup. So by means, these tests run externally just like what our customers experience. So we have deployed agents in multiple geolocations where we establish remote execution of these end-to-end tests backed by the Selenium framework. So this is how the new architecture looks like. And what other capabilities that we have added? We have dynamically distributed the test across servers, and the test and the accounts have been isolated so that in case of parallel execution, we don't end up in the race condition of same account is being used across the tests. And we have introduced a scheduled job running where we can schedule a particular synthetic test to run in a particular geolocation at a particular interval. And the real-time view of execution in the dashboard, so any execution that is happening currently and the previous and past with all those results, logs, and API responses will be benchmarked and will be available in the dashboard. And obviously, it is stored in the logs. And we have been introduced an alerting logic where any external system can create a webhook and receive those alerts in case of any failures. So these are the capabilities that we have added. And then this is a sample execution summary page where shows eBay synthetic test, the time of the test it has been run, the geolocation, and the result of the test. This is a summary which will be available for all those synthetic tests that have been executed. This shows a detailed summary of a synthetic test with all those stepwise details. Like you see, this is a sample checkout flow, get auth token, create token, login. So as you can see, there is a combination of API flow as well as a web flow. If you click on the view details link, then you will be able to see the screenshots, API requests and responses, the performance thing, the duration. At each step level, it is captured and benchmarked. So what are the insights that we have derived in that? So proactive signals for major incident detection and customer experience degradation. This is one insight that we constantly derive, thereby reducing the MTTD, mean time to detection of the incident, which is a key for reliable customer experience. And the second one would be TPV report. We run a weekly report of total payment volume report, which gives us a lot of data and insights on which product is contributing to the total payment volume, and so that we can identify whether that flow or the customer experience is going to be reliable and whether that has to be added in the synthetic test. And the third thing is AI. We are currently focusing on leveraging AI to generate automated scripts so that product development engineer can just focus on the business logic and it can be onboarded, the test can be onboarded at ease. And the final thing would be latency measurements, various across geos, is constantly monitored and we do benchmark it. Okay, with that I hand over to Rex for the features and takeaways.
Thank you, Anand. So by this journey, you would have seen that we've enhanced our end-to-end testing platform to Synthetics. And we've a lot of takeaways for all of you, and hope we have shared our experiences in building this platform. As you can see, change reliability is achieved through end-to-end testing. Customer flow validation, specifically for release sweating, is one of the key signals. We've been able to measure the accuracy of the end-to-end test, make it reliable, and have potentially blocked releases that are faulty. Synthetics is a customer feedback. I mean, like experience-wise, we've been able to derive a lot of insights from the tests that we execute. We went a very structured way, elucidating requirements for end-to-end testing, and built a Synthetics platform as a capability itself. As you can see, many of the features that we offer in Synthetics can be plugged in by the product development teams as well. And last but not least, Synthetics is one of the key signals for proactive incident detection. So this wraps up our talk, and I would like to take this opportunity to thank everyone for staying patient, and also USENIX for organizing the event and giving us this opportunity. We'll now take a few questions.